Welcome to class, student. How's your day going? Let's take this subtopic today, understanding speed. Speed is a function of distance and time. It is the distance traveled by an object per unit time. The unit of speed can be meters per second, kilometer per hour, or nautical miles per hour. Looking through this exercise, all these are the units for speed, except we have meters per second, kilometers per hour, Newton per second, no, nautical miles per hour, yes. So Newtons per second, that's correct. Now, speed is a scalar quantity. What do we mean by a scalar quantity? A scalar quantity is a quantity that has only magnitude, that is a specific value without direction. And we say speed has only value without any specific direction. True? Can that be true? Yeah. Calculating average speed. Methods to measure speed rely on making two measurements. We must know the total distance traveled between 2 points and the total time taken to do the same. When the distance between 2 points, say A and B, is measured, the average speed can then be calculated as total distance per total time taken. For instance, looking at this activity, a cyclist completed a 1,500 meter stage of a race in 37.5 seconds. What was our average speed? That means average speed will now be what? Total distance, which is 1,500 meters, divided by the time spent, that's 37.5 seconds. And that gives us, let's say, 40 meters per second. Now, measuring speed in the laboratory. Laboratory experiment can be done to measure the speed of a moving trolley or toy car. This is done with the use of two light gates connected to an electronic timer. The peg attached to the trolley breaks the pin of one light gate to start the timer. It breaks the second pin to stop the timer. The timer shows the time for the trolley to travel between the two light gates. Rearranging the equation of speed. The equation of speed can be rearranged, knowing fully well that speed is already known as distance per unit time. The equation can be rearranged to calculate distance or time. By way of rearrangement, we can make distance the subject of the formula. Distance now becomes speed times time, and it is measured in meters. Also, time will be equivalent to distance over or divided by speed. This is measured in seconds. Let's take this activity. A spacecraft is orbiting the Earth, a steady speed of 8 kilometers per second. How long will it take to complete a single orbit, a distance of 44,000 kilometers? Now, we know that speed is equal to what? Distance over time. Then time is equal to distance over speed. Now, time is equal to the distance now is 44,000 kilometers. 44,000 kilometers. While the speed is 8 kilometers per second. We have kilometer here. Here we have 8 kilometers per second. So the time by way of division, 4 here to 4 here, 11,000, and 2 here, 2 in 11, that's 5 in 110, that's 5,500. That becomes 5,500 seconds. Let's check. Correct. Now, a planetary and interplanetary spacecraft is moving at 20,000 meters per second. How far will it travel in one day? We have to give our answer in kilometers. With that in mind, our speed is equal to 20,000 meters per second. Don't forget that 1,000 meters is equal to what? 1 kilometer. That makes the speed now to be 20 times 1 kilometer. And that is 20 kilometer per second. Now, to travel the time for one day to be expressed in seconds, we have 1 times how many hours make a day? 24 hours times 60 minutes times 60 seconds. So, speed is equal to distance over time. Our time now, distance now will be what? Speed times time, and that is 20 kilometer per second times 24 times 60 times 60. And let's see what the answer will be. 1,728,000 kilometers. Is it part of the option? Let's check. Correct. Now, also rearranging the equation of speed, still dealing with some activity. A train begins a journey from a station and travels 60 kilometers, in a time 20 minutes. What is the average speed of the train? Distance is 60 kilometers, and the time given here is 20 minutes. Now, we know that 60 minutes, we know that 20 minutes rather will be equal to 20 times 60 seconds, and that gives us 1,200 seconds. For the distance to be converted to meters, we have distance that's 60 times 1,000 meters. Since 1 kilometer is equivalent to 1,000 meters, that gives 60,000 meters. So distance over time will now be 60,000 divided by 1,200. And that gives us 50 meters per second. As you can see, is correct. So a tunnel has a length of 50 kilometers. A tunnel has length of 50 kilometers. Distance, 50 kilometers. And it takes 20 minutes to travel between the two ends of the tunnel. What is the average speed of the car? We have to convert the minutes now to hours. 60 minutes is 1 hour. 20 minutes will now be 1 times 20 over 60. And that's 1 over 3 hours. Speed now is 50 divided by 1 over 3. 50 kilometers is the distance, 1 over 3 is the hour. So we have 50 times 3. That's 150 kilometers per hour. Can we see it in part of the options? Yes. Let's check. Now, for the summary of all what you've done in total, let's choose the correct statement. Average speed is described as the average displacement per unit time. If you should look at two keywords here, displacement and time. Displacement is in relation to velocity. So it can go with speed. Average speed, for the second one, average speed is prescribed as the average distance per unit time. As we've learned earlier under this topic, discover that distance goes with speed. So average speed is prescribed as average distance per unit time. The statement is correct. Looking at the third one, average speed is prescribed as the average time per unit distance. This is wrong. So we have average speed is described as the average distance per unit time. Thank you so much for your time. You can subscribe to our website to check more of our interactive classes and lessons on www.edubbey.com. Do have a great time.